So let's look at scatter plots. Tell me, what do you know about scatter plots?
Well, I don't know the definition, but I know what the picture looks like in mind. I know what the picture looks like. It's just like dots that are like scattered around.
This is the x-axis. This is the y-axis. Yeah? Scatter plots is scatter plots. Something that is plotted in a very scattered way. You don't have to remember any. I don't encourage kids to remember any definition. It's just about relating to it. Let's say when you say scatter plots, things which are plotted in a very scattered way. That's what it is. Now, why do we use this kind of a thing? Imagine a situation. Let me draw something. Let me say, in your school, in maths, they do test every month. Let's say they do January, they did in February, they did in March, April, December. Okay? They did test of one paper maths. Okay? And this is 30%, this is 40%, 80%, 90%, 100%. So this is the marks scored by any child. Let me not say that is you, because I'm going to plot some bad numbers also here. So let's say somebody in your class who is not very consistent with his studies, he gets, in January he got, let's say, 40% marks in the test. Okay, so this will be one where January 40%, this will be 1 point. Yeah, you have plotted in the XY frame. Let's say that guy did a lot of hard work in the February test and got
90%.
90%. Okay.
And shouldn't he go up? It just said January. He said February.
My bad. Good that you are paying more attention than me. So, in February, he got
90%.
90%.
So better than last time.
Better than last time. In March, again, this guy again went in a relaxing mode.
What?
No, I want to study.
They
Okay.
failed the test.
Failed the test. I got 30%. Let's not say failed. I got 30%. Now in April, the same boy did okay, slightly better, but not so great. Okay, so got just 40%. Then April got 80%. Then let's say May got again. May got let's say again 30%. Got 90%. And in let's say December he got 100%. Okay. So this kind of scenario, when you are plotting numbers in a two-dimensional graph, is called scattered plots. All these dots, the values that you are displaying here are called scattered plots. Here, based on the data that you see, what you can see is this. If I have to draw a line where maximum dots fit, I see this one is close to this one is close to this one. So if I draw one straight line where I see most of
it's increasing.
it's increasing, that is one trend. But I cannot say that because this guy, January he was 40%, February increased. But again March, this guy came down.
So it's fluctuating.
It's fluctuating. And if you look at these, if I have to draw a line where I can see all the points being very close to each other, I mean falling on this line or being close to this line, this is called line of best fit. Meaning, if you are looking at a scattered plot, meaning you have a lot of data plotted here. Let's imagine it is not only for one boy, you have let's say 10 boys scorecard being drafted, okay, and then you have all these points plotted here. This is also a scattered plot.
Okay.
And let's say there are 3 boys, so other ones are in blue color. A second boy is in blue color. Let's say second boy's marks are in blue color, okay?
Yes.
And there is a third boy whose performance is plotted in red color. So this kind of thing where you have a lot of data being plotted in a graph in against x and y axis, this is nothing but called scattered plots. You are just putting those plots, and from this you can use this data for deriving some interpretation. Let's say if lot of data is here, lot of dots you see is in the center, meaning this is where maximum information is. These are outliers, not the general trend. Okay, like this guy is scoring 100% in February. That only happened once. If this guy was consistent, he would have got
even more
in this one. But if you see, 100% is a very rare phenomenon. Only sometimes some people are doing it. So these are called outliers. Likewise, 30% also was secured by only one boy once in the entire year. So these are called outliers. This is where you see all the concentration, right? If I draw a line here, I will see most of the dots or maximum number of dots around that. That line is called line of best fit. That tells you that okay, this is where you have maximum information. If you want to derive a trend, look at the line of best fit. That gives you most of the information, except those outliers. Okay?
Yeah.
So that is what is called line of best fit. So far with respect to statistics, what we have learned, I'm just doing a recap of that, and then we'll try relating that with all the different types of graphs and charts we have learned, and what chart or graph is used for what kind of interpretation. So we have looked at bar chart, okay. Let's say this is the percentage scored by a boy or a student in the, this is let's say 30%, 60%, 80%, 90%. Marks scored by a child, overall percentage in different grades. Let's say this is 3rd grade, this is 4th grade, this is 5th grade, 6th grade, 7th grade. Okay? 8th grade. Okay? This is called bar chart.
Yeah, okay.
The parameters could be different. Here we are trying to plot somebody's overall percentage over the years or across different grades. So this gives me a view that okay, this child or this student is not very predictable. He or she has a lot of potential, because I see that same child is scoring 90%, 100% also. But then there has been times when the score is very low.
Yeah.
That means this boy or girl is not very consistent,
Yeah.
but has a lot of potential. So that from this data we can interpret that. Likewise, if you have to compare data against different, when you say, okay, you would have heard about something called what is my share of the pie. When you cut a pie, let's say you have 4 or 5 people in the family, right? You will always say, okay, oh, this boy likes, let's say you like apple pie a lot. I'm just making it up. So everyone will say, okay, yeah, Mithun is youngest of all, and he likes apple pie a lot. Let me give him a bigger share. He likes it a lot, so let him enjoy it. He gets a bigger piece of the pie. No, your dad will say, no, I don't like sweet that much, and moreover, apple pie is not my favorite. I'll just take a smaller piece. And then your mom says, okay, me and my elder child, we will distribute the rest of this one. Again, mom says, okay, I don't want much, give me the small piece, and rest can be given to the elder child. So, you're actually distributing that pie among different people, right? Mm-hmm. Same thing, same concept is used in statistics also. When you have to demonstrate distribution of something across different set of people, different set of units, companies, whatever, different entities, that is when you use the pie chart. Where this is the whole pie, nothing but a circle, which has nothing but 360 degrees from here to here.
Yeah.
Yeah? And you distribute, let's say if you have to distribute that equally among 3 people, you have to say, okay, let's say my grandfather's wealth, if that was distributed among my dad and his sibling, right? There were 4 child, let's say. So my grandfather's wealth, let's say he had 1 million. I know he did not have 1 million, but I'm just making it up.
I know.
So let's say he had 1 million and he had to distribute it among 4 of his children.
So for, I think that would be like 25,000 something.
250,000. 250,000. Because 1 million has 1,000.
Okay, so it's 25,000.
25,000. 25,000. 250,000. Because when you look at 1 million,
Yeah,
this has 6 zeros. Yeah. So this is what everybody got. My dad, my dad's all other brothers, our siblings. How can I depict that here in the pie chart? Okay.
25%.
My dad's brother 1, uncle 2, uncle 3. I'll put the name of the uncles, okay? And say, okay, this is 250,000. I can say 250,000, or I can also say 25%, whatever you say.
Okay.
Yeah? Or I can also say 90 degree. Because I am distributing the 360 degree among all 4. So everything here, if you see, this is angle 90 degree. This is angle 90 degree. This is angle 90 degree. Yeah? So pie chart is used for showing the distribution of something among different people. Let's say if my grandfather had a different plan. He said, no, I would not distribute the wealth equally. There are some kids whom I like more, there are some kids whom I like less. Some kids are deserving more, some kids are deserving less. So I will not distribute like this. I will say 30% to one kid. This is 30%.
Mm-hmm.
No, this is not 30%. This is less than 30%. So 30% will be more than 90 degrees. So let's say 30% to one kid. Okay, let's say my dad was favorite. He got 30%. 30% of 1 million will be what? 300,000. Now, remaining 70%, he says, okay, I will distribute among the other 3 child.
The other.
Let's say one uncle gets 20%, uncle 1 gets 20%, and then uncle 2 gets 40%, and uncle 3 gets 10%. So based on the distribution, this pieces will be of different sizes. That's why it is called pie chart, because it depicts a pie. How the pie is distributed among all the stakeholders is what it depicts. So let's say if you have to use this pie chart to represent something for your class. Let's say in your class of 50 students, 20 of them like maths, 15 like science, and another 15 like social studies. So you can depict that in a pie chart. If you do that in a bar chart, it will not look nice. It will just show you that distribution, but it will not show which one is bigger, which one is smaller, or how they are related to each other basically. Okay, how is that class distributed? So when you are showing the distribution, that is where pie chart becomes more. So you will say, okay, this part is maths, and you can put 20. Okay, and you will say, okay, this part is science. Okay, and you will say this part is social studies. This just makes it look more beautiful and easy to relate. Okay, so if let's say here, you had one more flavor where you had some kids who don't like any of the studies. They like sports, and that's a very small percentage. Sports. Okay. Let's say science has this one has, let's say, 17. This many, and then here you have 3 students. So by looking at this pie chart, you can make out that okay, my smallest of the group is sports, my biggest of the group is maths.
Okay.
So that's the purpose or the use of any of the statistical diagrams. These are called statistical diagrams. So these are diagrams or the charts that is used in statistics. Okay. Now, so we looked at bar chart, we looked at pie chart. There's another thing that you can do. That is called line graph. Okay. So you can say my age, this is age, okay? When I was 10, when I was 13, when I was 18, when I was 25, when I was 30, when I was 35, when I was 40, 45, okay? I'll not go beyond that, okay? What was my weight? This is, on this line I'm putting weight in pounds.
Okay.
When I was 10-year-old, let's say my weight was, this is let's say 10, this is 50, 80, 120, 160, 180. When I was, let's say, 10-year-old, my weight was, let's say, 54 pounds. When I was 13, I gained some weight and became, let's say, 68. When I was 18, I was growing fast and I gained weight. My bone became stronger and heavier. I became 85. Okay? When I was 25, let's say I became 122. When I was 30, I gained some more weight. I became 125. When I was 35, that time I had fallen sick for, let's say, 3 months and I had lost some weight. I'd come down to
30.
30.
40.
40. I gained a lot of weight. I became, let's say, 170, 75. So when you join these points,
Line graph.
this is what is called line graph. Okay. So mostly when you look at bar chart, you can do this like a bar chart also. This line graph could be the center of the bar chart. That also you can do, or you can do just like a line graph which just shows the trend. It's a thinner representation. Doesn't look very clumsy. If you're looking at bar chart, that takes a lot of space. So if you're running, if you have a need for making it short, crisp, less clumsy, less loud, you can use line chart graph also, because it is used for showing the trend. Bar chart is used for showing the data and trend both. Line chart is primarily for showing the trend. Okay. If you see a lot of fluctuation, you know that this data is not predictable. If you see like this, that means you see an upward trend. If it remains like horizontal, that means it is static, not growing, not going down. If you see it like this, that means there is a downward trend. Yeah. So that's the purpose of line chart. And then we saw scattered plots today. So scattered plots are nothing but a representation of all the data in a two-dimensional graph. Yeah. Let's say you have to plot the score by 50 students, okay, in one exam. So here, let you put the marks this way: 10, 20, 30, 60, 90, 100. You put so let's say there are 5 exams. I made it very. So let's say there are exams done in 5 or 3. There are 3 terminal exams done. 1, 2, 3, and then you plot the marks by all the 50 students. Terminal 1. You saw some people scoring 60, 70 also. You saw some kids scoring 90 also. We are plotting 50, for 50 students. This is terminal 1. Then we did terminal 2 exam. We saw that everybody got better. Kids became more serious, did better in the second exam, meaning the score was more. There were some kids who were still not paying attention, not studying well. Yeah? Then you look at terminal 3, the third exam. Everybody was serious, very, very serious.
Everyone did better.
Much better. Some kids who are more into sports, who are not serious about studies, they continued performing that way. So this scattered plot gives you that view of the data. By looking at this data, you can always say that if you have to look at where the majority of data is, this is this zone. This is outlier. There are some students who are not performing well at all. There are some students who are scoring exceptionally well. But that is not my mass. My mass, the 70 to 80% of the population is in this range. And that is why you draw a line cutting through this zone of maximum data. That is what is called line of best. What is the term used?
Line of best.
Line of best. Let me look at the term. I keep forgetting it. Line of best fit.
Okay.
You will see that okay, this data is very close to this data. A lot of data is falling on this line, and many of the data is very close to this one, not very far. So that's what is called line of best fit. So we have learned about the scatter plots, we learned about bar chart, we learned about pie chart, we learned about line graph, we learned about scatter plots, a line of best fit. Let's look at one more thing that is called Venn diagram. Do you know what is Venn diagram?
Yeah.
Okay. That will be the last thing that you would want to learn today. Let's see how much time. Oh, we are going very fast just because it's only you.
What time is it?
It's 5:37.
5:37.
Yeah, so great. So let's spend some time on Venn diagram. So when does the Venn diagram come into picture? Let's say I have a group of students in 7th grade. I have another group of students that is in 8th grade. Is there anything common here? Cannot be, because these are two different grades. These are two disconnected grades. Now let's look at how you will see in the high school, where you will have kids from 9th grade, kids from 10th grade, kids from
6th grade.
now 9th, 10th, 11th and 12th grade.
So high school.
In the high school. And these circles are nothing but the AP subjects. AP subjects taken by AP subject 1, let's say, taken by 9th grader, AP 1, okay. This is AP 1, same subject taken by 10th grader, okay. AP 1 taken by 11th grader, AP 1 taken by 12th grader. What you can see is that between, if you look at this circle and this circle, okay, between 9th and 10th grade, there are some students who have taken this particular subject, which is common. Similarly, if you see between, this is 9th grade, this is 10th grade, here if you look at this part of this intersecting section, there is something common between these two circles, meaning some students in 9th grade have taken AP1 and some students in the 10th grade also have taken the AP1. That is common here. Similarly, if you look at this circle and this circle between 12th grade and 9th grade, if you look at just this piece, this one we talk about, okay. If you look at this piece, this one is common between 10th and 12th grade also. So here what I'm trying to depict is, when you have two sets of data and some data is common between both the sets. Let's say, let me give you a simple example. Let's say in your class, the boys, and this is girls. This among all the boys and the girls, we are just trying to depict all the kids who like science, who have opted for science. This is the group of boys and girls which is common here, and they have taken science. Meaning, remaining boys that you see here have taken some other subjects. The remaining girls that you see here, they have taken some other subject.
Yes.
This is the only intersecting point where they have something in common here. You can think of different scenarios where you have data coming from two groups and something is common. When you represent it like this, to two circles representing two sets of data and something being common, that is what is called a Venn diagram. Okay, you can look at different scenarios. There is no hard and fast rule. It only has to be not age, it only has to be subject, or it only has to be score. But essentially what it means is a Venn diagram is used for denoting two different sets of data where you have something in common. Something common between both the groups. Okay?
Okay.
That is what is Venn diagram. And when we do more and more sums, you will see this common thing is used for deriving the. Okay. Now let's look at one sum here with the Venn diagram. It will not take more than 5 minutes. I'll still be able to let you go by 5:45, but let's spend 5 more minutes. Now let's look at a scenario. Okay. So let me frame a question here, okay? In a class there are 60 students. Okay?
Okay.
30 of them like maths. 45 of them like science. Okay? And 20 students like science and maths. Okay? Science and maths. Let me see if this question is correct or not.
Wait, in statistics, they can sometimes give problems in the word problem form.
Yeah.
Oh, okay.
This is called context-based problem. And interestingly, these are the questions that are asked more. And this is where you have more chance of scoring more as well. Because this takes more effort, you have to read it, interpret it. So they give more weightage for these questions and then you get more score if you do it right.
Okay.
So I'm just checking. Okay. Now the question is, how many of them, of the students, like only science? That's the question. So there is a class of 60 students, 30 of them like maths, 45 of them like science,
And 20.
20 like science and math both. Okay. How many of the students like only science? Think about it. Can you try doing it? The clue that you have is you can use a Venn diagram to simplify this. You can try it out.
Is it 65?
How many of the students like only science? So there are total 60 students. you will never have students who like only science. It's among 60.
160. So it's 45.
45 of them like science, but that doesn't mean they like only science. My question is, how many of them like science? See, there could be some students who like science and also like maths, which I have already told. 20 students like science and math both. So you have to tell me how many students like only science. Only science.
It's supposed to be 65, but I'm confused because if you add 30, 45, and 20, it would give you 95, but there are like 60 students.
Yeah. So that's where Venn
Wait,
diagram.
wait. I think I might get it.
Yeah. That's why I make you think. Then you'll get it right.
Was it 5?
You have to show me. I don't know the answer. This is a question that I made up on the fly.
Was
So
the answer 5? Because since there's like a large amount of students and 20 like math and science and 45 like science, and then if you add them up, you get 65. If you subtract 60 from 65, you get 5.
okay, let's do it afresh. Okay, this is how I will do it. Okay, I made this question on the fly. I don't know whether this question is right or not. Okay, but whenever I get a question, that question might be done incorrectly by somebody else also. I will read this question again and again. It says there are 60 students in a class. Okay, so let me say this is my class. I have total 60 students. At any point in time, I will not have 61, I will not have 59. This is my total class strength. Now, 30 of them like maths. Let me put 30 is a circle.
Wait, I think I understood when it was a problem.
Okay. Now you use the same clue and try doing it.
I forget it.
Okay. Now let's say this is my group of students liking math. Okay. 30 of them like maths. So this total, everything inside the circle is 30. Everything inside the circle, okay, is 30. Okay. Now, 45 of them like science. So let me make another circle. This is science circle. Okay. This is 45. Okay. Now my total strength is 60. At any point in time, this and this sum cannot be more than 60. That means there is something common here.
So was the answer 15?
I will do it. I will do it to figure out. I don't know the answer yet. I mean, I'm still doing it. Okay. So let's say now let's do it together. So there are 60 students in the class. Total is 60. This is my class. 30 of them like math. So this is my circle for math. It's 30. 45 of them like science. So this is my circle of science. It's total 45. Okay. Everything inside the class. Nothing going from outside. Now 20 students like science and math both. So this is my intersection between these two circles. This is the group of students, 20 students who like science and math both. Now total students for science is how many? 45. This is taken 20. So this part is remaining is 25. What is this part and what is this part? How many of the students like only science? See, this part, the colored green one here, is the group of students who like maths and science both. What this side says, everything white here, is the students who like only science. What this part says, only math. The question was, what is the total count of students who like only science? So in this circle of 45, 20 is taken by this common piece. What is remaining is 45 minus 20. That is the, because my total group of students who is liking science without any disclaimer is 45. Out of 45, there are 20 students who like science and math both. That is by the intersection of the Venn diagram. So what I have remaining here in white outside this one is the group of students who like science and they only like science. If somebody says, what is the total number of students who like only maths? What will be that value?
30.
Now, 30 is my total count of math. 30 of them like math. 30
So 15.
What is total count?
20.
20 like science and math both. Science and math both is this part, common between these two circles. So whatever is here this side is only math. Whatever is here this side is only science. And this is the group that says science and math both. That is the purpose of a Venn diagram. In the Venn diagram, when you see two data, if you look at this part that I am coloring right now, this is present in this circle, here also. If you look at this circle alone, this is present in this circle also. So that is that 20 students like science and math both. That is common in science, that is common in math. Whatever is remaining is outside that common group. So if you have to look at science, which is 45, total circle is 45. If you cut this piece out, then you are left with 45 minus 20. If you have to look at this part, it's only math. Total is 30 for this circle. If you take this piece out, what you are left with 30 minus 20 is 10. Make sense?
Yes.
So that is what Venn diagram helps you solve. If you look at this question,
Wait, so the answer was 10 all along?
10 for only math. Our question was how many of the students like only science? Science is this circle. Math and science common is 20. Total science is 45. You take 20 out of that 45. What you are remaining left with is 25. That is your count of the students who like only science. Because other 20 students like science and math both. So when you exclude that group, you are left with this, which is explicitly for science. Same way, if you have to look at all the students who like only maths, you will take out this group, which is math and science combination, and then you are left with what is only maths. So this Venn diagram just gives you a very intuitive view of how you will draw it, how you will get that value. If you had to solve this problem without visualizing this, without looking at this diagram, it would have been a little difficult. When you use the Venn diagram, it helps you visualize what data you are talking about. See, 20 students like science and maths. That's why when I was drawing the two circles, I made sure that there is an overlap between these two circles, because that is my common part. Something that is present in both the places. Yeah?
Mm-hmm.
So that is how Venn diagram helps. I'll give you guys some more sums. When you do it, you'll be able to kind of practice that and becomes much easier. These are not difficult stuff. These are easy ones. Just a matter of visualizing it right. Because look at it one more time. Let me know if there is something that is looking complicated.
What is the answer for the science one again?
Okay.
How many students like only science?
Okay. So that means there is something that I need to explain again. Okay. So I always say I don't care about the answer. What I care about is the approach. So let's look at it one more time. I mean, see, again, why I'm not trying to give you the answer, because if I focus on answer only, you'll be able to do this one right. But if any question comes with similar type, you might go wrong. Now let's look at this question again from beginning, okay? There are 60 students in a class. I'm drawing my classroom with my limited skill on drawing. This is my classroom. It has all types of students, some boys, some girls, some kids liking math, some kids liking science, some kids liking both, whatever. Some kids not liking study at all also. But let's look at the question. 30 of them like math. 30 of them like math. I like math. I like physics. I like chemistry also. That is how I could compete in engineering. If I liked only math, I would have probably not got selected in the entrance.
You just be a math teacher.
Just a math teacher like now, right? So, what that means is, you cannot survive, or most of the students don't just like or do one subject, right? I mean, like for you also, right? You're in 7th grade, but are you studying only one subject? No. Are you reading multiple subjects? Yes, you are. Are you liking all of them? Probably not. But you still have to study them all so that your overall CGPA doesn't go for a toss. Yeah? So here, 30 of them like maths. So the statement is 30 of them like math. Okay, 30 of them like math inside the class. That is inside the class. Okay? I'm doing it in like a layman's way. Okay? I'm not doing anything strategic, anything complicated here. So treat me like a normal human being. I'm not being a mathematician here. I'm just reading it and plotting it. Okay? So 30 of them like maths. Okay, very good. I will read next two sentences. 45 of them like science. So there will be one more circle like this. Let me say math and 30. Whole circle is 30. I'm reading next two sentences, okay? 45 of them like science. So what it makes me believe, using my technique, TRAN, read and analyze. I'm doing reading and analyzing right now, yeah? That there will be one more circle for science with 45. But let me see what extra information I have here. 20 students like science and math both, meaning there is a group of students who like both the subjects. Meaning if I am drawing a circle here for science, that circle is going to have some overlap with this, because that will depict the group of students who like both the subjects. So that is why I have to make a friendly circle, a circle who is this guy's friend and has some overlap. This is my science circle, which has 45 students. Now I know these 20 students like science and math both. That means these 20 students are there in this circle and are there in this circle also. And this is my common part where both the circles are overlapping each other. So this is my 20. This colored part is 20.
Yes, okay.
So now, if I look at only this circle, what do I have? I have this colored part and I have this white part.
Okay.
Out of my 30 students total, 20 is colored, rest all are non-colored. What is that colored 20 mean? Those 20 are the students.
I get it. And since that 20 is shaded, it's eliminating the part of the circle. So
Yes.
it'll be 10.
10 will be the one that is white, not
So
colored.
it's the same thing for the science one.
Yeah, yeah.
So
you got
if
it.
you do 40 25.
Yeah, now you got it. So, see, there's nothing fancy about this. We are just trying to put our understanding in a very intuitive way. That is what Venn diagrams helps you with.
Okay, I got it now.
Yeah, makes sense? You might come across a situation where they say, okay, there is one more circle for English.
Then you might have to eliminate all 3 circles.
So that's what I'm saying. So when you get that question, you put the data here and then try looking at how do you interpret the data to derive a conclusion. That is the purpose of statistics. By using Venn diagram, by using bar chart, by using line graph, by using pie chart, by using line diagram. Everything is helping you to derive some conclusion by looking at the data without dealing with the struggle of math too much. Okay? That's the purpose of statistics. I hope whatever we have covered here makes some sense. You're able to relate them, right? And once you do some sums, that will help you to strengthen your understanding and make sure that you're able to play with it. Yep.